Hey everyone, this is the first video for section 8, which is going to be on solving linear equations. I'm actually going to combine 1 and 2 step and multi-step all in one video because everyone's going to be at coming in at a different level in this course. Some of you might need to view the 1 and 2 step, some of you might need to just view the multi-step. So in one video, you can just fast forward to the part that you need, okay? So we're going to start with 1 and 2 step algebra. If I have x plus 7 equals negative 5, first of all, I want you to think about what an equation is telling you. This is just like a seesaw or a balance being balanced right here at the equal sign. So this is telling you whatever is on the left side is exactly the same as what's on the right side, okay? That means that whatever you do to one side, you have to also do the same exact thing to the other side, otherwise you are tipping the scale, okay? In order for me to get x by itself, and that's always the ultimate goal, is to get x by itself. That's what solve for x will mean, okay? It's going to say solve for x, which means get x by itself. I have to remove anything that is attached on that side to the x. So right now there's a plus 7. I don't want to know what it is with plus 7 on it. I need to remove that 7. So if I take away 7 from this side, I also have to take away 7 from the other side. Some students also like to put a line underneath the equals to show the work has to be the same on both sides of the line of the separator. All right, that's up to you. When I do that, I'm left with x equals negative 12. Okay? When you perform a check, which I know a check's not really needed for a one-step problem, but I'll just show you here. When you perform a check, you're going to plug in, again, with parentheses, although they're not totally needed here, but I think it's a good habit, negative 12 plus 7, but you are not going to put an equal sign in, okay? So no equals in a check. The reason why there's no equals in a check is because if you made a mistake, you can't say that the two sides are equal, okay? You have to prove it first. So this is going to be negative 5, and of course negative 5, they balance, and so I can say that that works out, okay? The nice thing about all levels of algebra is that they are checkable, okay? So one step to multi-step, all right, these are going to be checkable just by plugging back in, all right? Now let's do what happens if it's connected by subtraction. Let's say you have x minus 5 equals 4. Again, you can put a separator here or not, it's up to you, but whatever you do to one side of the equals, you have to do to the other. I want to get x by itself. Again, it's going to say solve for x, which ultimately means get x by itself. Right now, it is less 5, okay? I want it to gain 5, so this way I can get x, all right? Take that deficit away. But if I plus 5 here, I have to plus 5 here. So this is going to give me x equals 9. And again, you would do a check the same way. I don't think this one necessarily needs a check, okay? So this is how you handle pluses and minuses. Again, these are one-step problems. Now let's do one-step multiplication and division. Let's say we had 4x equals 20, and it's the same solve for x. That means get x by itself. Right now, it's connected by multiplication, 4 times x. Okay, so in other words, 4 groups of x gives us 20. I don't want to know about 4 groups. I want to know about 1 group. So I have to divide by 4 and divide by 4. Again, the work has to look the same on both sides of the equals. 4 divided by 4 is 1, so I just have my 1x left. And then 20 divided by 4 is 5. And again, doing a check is just about substituting it back in. Now let's do a division. Let's say we have x over 5 equals -3. It's going to say solve for x. Right now, the 5 is connected to the x with division. Okay, how am I going to remove division? We talked about this when we did exponential functions. We want to multiply by 5 to get rid of the division, but whatever we do on this side, we also have to show on the other side. And so this is x equals -15. Okay. Now we're going to look at some two-step problems. Okay. Let's say we have 7x plus 4x equals 22. Okay, and we're being asked to solve for x. This is why we had to learn about simplifying expressions in the last video. Right now, I have 2 different terms with x in it. I have to get that into one term. Otherwise, I'm not going to be able to get x by itself. Because again, that's what this means. Get x by itself. I can't do that unless they are in one term. These are like terms, so I can combine them. This is going to give me 11x equals 22. Okay, so here, what did I do first? I combine like terms, or in other words, I simplified the expression first. That gives me this, and now I have to get x by itself, so divide both sides by 11, and I get x equals 2. Let's actually perform a check here because it's getting a little more involved. I have to always check in the original, not when I do any work, okay, in case I made a mistake. So 7 parentheses 2 plus 4 parentheses 2. Remember, no equals in a check. Does that give me 22? Okay, I just need to see if the 2 sides balance each other. This is going to be 14 plus 8, which is 22, and I've performed my check. Okay, so this is a 2-step problem because this took 2 lines for me to solve the problem. I had to first simplify the side of the equation, and then I had to solve. Okay, so this is what I would consider 2-step. Let's look at another example of 2-step. It could be 2 different operations. What if it's 4x minus 20 equals -8? And it says solve for x. We want to get x by itself, but we have a couple things happening to the x. It's multiplied by 4, and then there's also a takeaway 20 attached. You have to go from the furthest away going in, okay? So the minus 20 is easier to pick off. We're going to add 20 to both sides. That's going to leave us with 4x equals 12. Then divide both sides by 4, and I get x equals 3. Okay? Again, why is this 2 steps? Because it took me 1 line and 2 lines for me to solve this. So that's why I consider this a 2-step problem. Okay? What if it looks a little backwards? what if it's 4 minus 2x equals 10? Okay? It doesn't matter which side x is on, all right? I still need to work my way in towards x. This is a positive 4. Okay, the opposite of positive 4 is minus 4. So take 4 away from both sides. So now I get negative 2x equals 6. Keep in mind, this negative is attached to this term, so it has to come down. Divide by negative 2 on both sides, and I get x equals negative 3. Doing a quick check here again, this would be 4 minus 2 parentheses negative 3. Always plug in with parentheses. Does that give us 10? Remember, no equals here. This is going to be negative 2 times negative 3, which is plus 6. And of course, we get 10. Okay, so it balances on both sides. All right, so this is your 2-step. Now I want to move on to a quick fraction. Let's say I have 2/3 x equals 6. Okay. I can do this actually 2 different ways. I can either do it as a 1-step problem, or I could do it as a 2-step problem. So I'm actually going to show you both ways. We'll do this one as a 1-step, and then we'll also do it as a 2-step, just so you can decide which one makes the most sense to you. If you do it as a 1-step, you are going to view this fraction as just one thing. This is 2/3 times x equals 6. Okay? How do I get rid of multiplication? I'm going to divide. But when I divide fractions, okay, so I'm dividing here by 2/3. When I divide fractions, I really multiply by the reciprocal. So we're going to write that out. When we divide fractions, we really multiply by the reciprocal. If you're rusty on your fraction vocabulary, reciprocal means the flipped version of the fraction. So we're not going to show it like this because this looks very confusing. We're going to multiply by the flipped version of the fraction. So multiply by 3/2, multiply by 3/2. The way that you multiply fractions, you can put this over 1. Any whole number can go over 1, is straight across. So these 2's disappear and these 3's disappear. That's why we wanted to use the reciprocal. And so we're left with x equals 18/2, which is 9. For those of you that do feel comfortable with cross canceling, you could also cancel this. 2 goes into 6 3 times, and 3 times 3 is 9. All right, this all depends on your comfort level. Now let me show you it as a 2-step. 2/3 x equals 6. The x can always be written with the numerator. So this is the same thing as 2x/3 equals 6. If I view this as a 2-step problem and work my way towards the x, the first thing I have to get rid of is this 3. It's dividing, so I have to multiply. So multiply both sides by 3. That'll give us 2x equals 18. Now I have to get rid of the 2, so divide both sides by 2, and x equals 9. It doesn't matter to me which one of these that you prefer, okay? They're going to get you the right answer. This one is probably a little more straightforward because it directly comes from what we learned at the beginning of this video. All right. Now let's move into multi-step equations. I want to take 4 times 2x minus 6 equals 16. The first thing that I'm going to want to do here is I'm going to want to simplify each side separately. That's the first thing I'm going to want to do. This is why we had to learn about expressions first. So I'm going to distribute this. This is going to give me 8x minus 24 equals 16. Now I can branch my way in towards x. I'm going to add 24 to both sides. So I get 8x equals 40. And then last but not least, divide by 8. And so x equals 5. Again, let's do a quick check here because we're getting a little bit more involved. 4 times 2 times 5 minus 6. Does that give us 16? PEMDAS from the inside out. So this is 4 times 10 minus 6, which is 4 times 4. Look at that. That is 16. And so my check works. This is an example of a 1, 2, 3 step problem. Okay, because I had to do basically 3 lines of work to get to the final answer. Is it possible for there to be x's on both sides? Absolutely. Next example, 4x minus 6 equals 2x plus 10. Okay. I need to make sure x's are on one side and numbers are to the other side. So we want to get x's on one side and numbers on the other. Because remember, it is all about balancing that scale, all right? I'm going to recommend, so these are my suggestions. You don't have to do it. These are just my suggestions. I'm going to recommend moving the variable first and doing it in such a way that it stays positive if possible. Might not be possible, but it's just a good recommendation. So we're going to look at variables first, and we're going to try to move them in such a way that the variable stays positive. Well, I have 2 choices then if I look at the variable first. I'm either going to take away 4x or I'm going to take away 2x. If I choose to take away 4x, that's going to give me a negative number. That's not a horrible thing. You can still do the rest of the problem with a negative number, but we would love it if we could keep it positive. So I'm going to take away 2x from both sides. So I get 2x minus 6 equals 10. I successfully moved the numbers this way. So that means I have to move, or I'm sorry, the variables this way to the left. Now I have to move the numbers to the right. I'm going to add 6 to both sides. 2x equals 16. Now I can get x by itself, divide by 2, and so x equals 8. Okay, so we can get our variables to one side and our numbers to the other side. Okay. Next example, 2 parentheses x minus 5 plus 3x equals x plus 18. Simplify each side separately. Okay, so look at each side separately. So that's what we're going to do first. Simplify each side separately. So that means I have to focus on the left side. distribute the 2. 2x minus 10 plus 3x equals x plus 18. I'm still not done simplifying because I can combine like terms as well. So this is going to be 5x minus 10 equals x plus 18. Now I have to get letters on one side and numbers to the other. And again, following the suggestion, I would try to move them in such a way where the variable stays positive. So I'm going to take away x from both sides. That gives me 4x minus 10 equals 18. Add 10 to both sides. 4x equals 28. And then divide by 4. And so I know that x equals 7. Okay, and again, you can check all of these. I don't want to spend more time in the video doing a check, all right? You can do the checks on your own if you prefer. All right, there are going to be situations where the answer cannot be simplified, okay? Or it can just be, it can't divide evenly, okay? What if that happens? So what if I have 3x equals 7? All right, going back down to just one step here. And I go to solve for x and I divide by 3. 7 is not divisible by 3. I can't do anything with this. So what I'm going to do is I'm going to leave it as a fraction. We talked about this in a previous video. This is called exact form, which means we leave as a fraction. Fractions are going to be our friends, okay? So we want to leave our answers as fractions if we can. All right. Last but not least, let's do a slightly longer one, and then that'll be the end for this video. 4 parentheses 2x minus 6 plus 9 equals 3 times x minus 7 plus 8x. We have to simplify each side separately. That means that I have to simplify this side with distribution and simplify this side with distribution. I get 8x minus 24 plus 9 equals 3x minus 21 plus 8x. Again, I'm still in the simplify mode. I'm looking at each side separately. I've got like terms here, negative 24 plus 9. And if you can't do that in your head, do it in your calculator. That's going to be 8x equals 8x minus 15 when I put that together. And then on this side, I've got a 3x and an 8x, so 11x minus 21. All right, the simplification part is done. Simplify each side separately. Now get the variables to one side, numbers to the other side. Subtract 8x from both sides. Negative 15 equals 3x minus 21. Add 21 to both sides. Okay, again, don't worry about it if you have to put this in your calculator. This will be 6 equals 3x. Divide by 3, and I get 2 equals x, or x equals 2. Okay? And again, you can go in and you can substitute on both sides with parentheses and make sure the two sides balance. So you will always know if you have the correct answer to these algebra problems. All right? In the next video, we will talk about situations where you may not necessarily be able to check because there are some special cases. So just keep your eye out for that next video. If you have any questions, please don't hesitate to ask.